When we envision humanity's greatest engineering marvels, we often think of colossal skyscrapers, monumental bridges, or sprawling metropolises. These structures represent our endless ambition, our drive to shape the world according to our vision. But among these astonishing creations, one project stands apart, not merely because of its size, but because of its extraordinary ability to influence something as fundamental as the rotation of our planet itself. That project is the Three Gorges Dam in China, a structure so massive, so dense, and so imposing that it subtly yet measurably affects how the Earth spins on its axis. Located along the majestic Yangtze River in China's central Hubei province, the Three Gorges Dam is more than just a feat of human ingenuity. It represents a profound shift in humanity's relationship with our planet. Completed in 2012 after decades of planning, construction, and debate, it stretches an astonishing 2,335 meters from one riverbank to the other. At 185 meters tall, it towers high above the riverbed, creating an immense reservoir holding around 40 cubic kilometers, equivalent to 40 trillion liters of water. This vast reservoir extends hundreds of kilometers upstream, dramatically transforming the local landscape and displacing vast quantities of earth, water, and sediment. While its primary purpose is to produce clean hydroelectric power, making it the largest hydroelectric facility in the world, the Three Gorges Dam also provides crucial flood control, helps regulate shipping traffic, and supplies water for irrigation and domestic use to millions of people. But the sheer scale of this dam brings with it some extraordinary and sometimes unintended consequences. One of the most surprising effects is its measurable influence on Earth's rotation, an astonishing concept that has captured the imagination and curiosity of scientists worldwide. To understand how a human-made structure could influence our planet's rotation, it's essential to grasp how Earth's spin operates. Our planet rotates around its axis once every 24 hours, a constant rhythm we call a day. Yet this rotation isn't perfectly uniform. It can speed up or slow down slightly, depending on various natural factors like earthquakes, volcanic eruptions, shifting ocean currents, or even atmospheric changes. But perhaps more intriguingly, human activities can also influence this delicate rotational balance. Enter the Three Gorges Dam. Its reservoir, when fully filled, shifts trillions of liters of water from flowing freely downstream into a massive static body of water held at an elevation of about 175 meters above sea level. Imagine placing an enormous weight near the surface of a spinning globe. This redistribution of mass affects how Earth spins, altering its rotation ever so slightly. NASA scientists have closely studied the effects of massive infrastructural projects, including the Three Gorges Dam, on Earth's rotation. Dr. Benjamin Fong Chao, a prominent researcher from NASA's Goddard Space Flight Center, explains that our planet's rotation is governed by its moment of inertia, essentially how Earth's mass is distributed around its rotational axis. When large volumes of water accumulate at a new location, like behind the dam's imposing walls, it subtly increases the Earth's moment of inertia. This can slightly slow the rotation, much like how an ice skater spins more slowly when extending their arms outward. Precisely measuring this effect has yielded fascinating results. The filling of the Three Gorges Dam reservoir has increased the length of a single day by approximately 0.06 microseconds. To human senses, such a tiny fraction of a second is completely imperceptible. Yet to astronomers and geophysicists who measure Earth's rotation with extraordinarily precise atomic clocks and satellite-based techniques, this change is significant and noteworthy. Additionally, the redistribution of such an immense water mass has shifted Earth's rotational axis by approximately 2 centimeters, another subtle but scientifically measurable impact. These minute changes underscore the astonishing interconnectedness of Earth's various systems. They remind us that even small shifts in planetary conditions can produce measurable global effects, echoing far beyond the immediate geographic region around the Yangtze River. Yet to fully appreciate this phenomenon, we must consider what makes the Three Gorges Dam so uniquely capable of altering Earth's rotation. It is, first and foremost, a matter of scale. While countless dams around the world store vast quantities of water, few come close to matching the sheer volume of the Three Gorges Reservoir. Its 40 trillion liters of stored water weigh approximately 40 billion metric tons, a mass comparable to enormous geological features rather than typical human infrastructure. Furthermore, the placement and elevation of this water are equally significant. The dam has effectively relocated an enormous weight of water hundreds of kilometers from where it naturally would flow into the East China Sea, placing it instead at a higher elevation, hundreds of meters above sea level. It's this vertical shift in mass distribution, moving a colossal weight higher and further inland, that exerts a measurable effect on Earth's rotation. The notion that human infrastructure could impact something as fundamental as planetary rotation leads naturally to broader implications. It forces us to reconsider the way we approach engineering megaprojects and assess their global consequences, both intended and unforeseen. The Three Gorges Dam symbolizes humanity's relentless pursuit of technological advancement and the harnessing of natural resources. The electricity it produces, around 22,500 megawatts at peak capacity, supplies millions of homes, dramatically reduces reliance on fossil fuels, and significantly cuts carbon emissions. It has undoubtedly transformed China's energy landscape, aiding in the country's ambitious drive toward renewable energy. But alongside these remarkable benefits, the dam has introduced profound ecological and environmental challenges. The inundation of vast areas to form the reservoir displaced over 1 million people, submerged thousands of cultural and archaeological sites, and significantly altered local ecosystems. Fish migration patterns have been disrupted, biodiversity has declined in certain regions, and sediment flow, critical for downstream agriculture, has been dramatically altered. Thus, the slowing of Earth's rotation is emblematic of a larger truth about large-scale engineering projects. While providing undeniable benefits, they simultaneously carry significant environmental and geological consequences. The Three Gorges Dam, therefore, serves as both an inspiration and a cautionary tale, highlighting our capacity for achievement, but also warning us of the delicate balance inherent in manipulating natural systems at massive scales. The recognition of human influence on Earth's rotation raises a broader philosophical question. As our technology allows us to reshape the Earth itself, how should we responsibly manage that power? The dam demonstrates that our technological reach now extends far beyond mere environmental or local impacts. We are entering an era when humanity's activities, whether deliberate or accidental, affect global planetary dynamics, a reality requiring thoughtful stewardship. Looking forward, how should such insights guide future projects? Should engineering practices evolve to better consider their planetary scale effects? These questions become increasingly relevant as humanity embarks on even larger endeavors, from enormous urban expansions to ambitious geoengineering schemes designed to mitigate climate change. As humanity moves further into the 21st century, the Three Gorges Dam's impact on Earth's rotation stands as a powerful metaphor for the global consequences of local decisions. It reminds us vividly that there are no isolated actions on our interconnected planet. Every significant alteration we make ripples outward, subtly reshaping the balance that sustains life as we know it. Interestingly, the idea that large reservoirs can influence planetary rotation is not entirely new. Geophysicists have long understood that natural phenomena like earthquakes, volcanic eruptions, and seasonal changes in polar ice sheets can alter Earth's rotation and tilt. Yet the Three Gorges Dam marks one of the clearest examples where human construction has produced a measurable planetary impact. It is a remarkable validation of our advanced measuring capabilities and simultaneously a humbling recognition of the scale of human influence. Future research utilizing even more precise satellite observations, advanced gravitational measurements, and improved computational models will continue to deepen our understanding of how infrastructure projects affect Earth's dynamics. NASA and other scientific institutions closely monitor the Three Gorges Dam's effects and similar large-scale projects worldwide, allowing us to refine predictive models and improve planning and management practices. Ultimately, this awareness brings with it an essential responsibility. As humanity's engineering ambitions grow ever larger, whether constructing dams, artificial islands, or massive urban centers, we must embrace the profound ecological, geological, and planetary responsibilities these projects entail. It challenges us to develop strategies that balance human progress with ecological sensitivity, ensuring that the benefits of infrastructure developments outweigh their unintended consequences. Moreover, the Three Gorges Dam exemplifies humanity's powerful role as a geological force. We now influence Earth's climate, atmosphere, oceans, and even its rotation, positions previously reserved for the colossal forces of nature alone. It is a stunning realization that humanity's technological achievements have become planetary in scope. This understanding marks a new chapter in our relationship with the Earth, compelling us to act with an increased sense of global accountability. Thus, as we marvel at the Three Gorges Dam and reflect on its engineering brilliance, we also pause to consider its deeper lessons. It reminds us of the profound interconnectedness of Earth's systems and challenges us to accept responsibility for the global impacts of our technological advances. It teaches us to approach future projects with greater humility, foresight, and respect for the planet we call home. In the final analysis, the story of the Three Gorges Dam and its subtle impact on Earth's rotation is not merely about the astonishing capabilities of engineering. It is about human maturity, ecological stewardship, and the wisdom we must cultivate as our power over Earth's natural processes grows. It is a story that invites contemplation, caution, and care as we continue to shape and reshape our world in unprecedented ways. The Earth is indeed slowing down, however slightly, and humanity's fingerprint is undeniably upon it. What remains now is how we choose to carry this knowledge forward, guiding our actions with awareness, respect, and a profound appreciation for the delicate, spinning planet we all share.